All right, students, Ms. Slyman here with example 6. Now we're wanting to sketch the graph of this function, but this function is not yet in factored form. So I need to put it in factored form. Notice x minus 1 cubed is my GCF. So I'm going to come down a little bit below and write that out. So if I take out my x minus 1 cubed, that's going to leave me with an x minus 1 here. It's going to leave me with a minus 4 here. All right, so continuing to write that out, that means I'll have x minus 1 cubed times x minus 5. So now I see that my roots are x equals 1, and that's repeated 3 times. So remember, that means it's going to go through my axis looking like a cubic. And I've got x equals 5, which I'm just going to go through. So this should say repeated 3 times. My y-intercept, when I plug in 0, I'm going to get negative 1 cubed, which is still negative 1. Negative 1 times negative 5 is positive 5. So I don't really have positive 5 showing up here. 1, 2, that's a bit of a, I don't know, a misgraph drawing. 1. So let's see if I can pull this down and make this actually be my x-axis down here. So then this would be positive 3, this would be 5 up here. So let's make that our x-axis. All right, so now I've got roots at 1, and I've got root at 5. My other root is also x equals 5. All right, and now the shape of this, I've got my leading coefficient is a positive 1, so that's a to the 4th. My n is to the 4th power. So this looks like a quadratic, but I've got some bumps in it. So I've got to start up and end up. So I'm going to come down. Here, it's going to look a bit like a cubic. So we could really, this little bit, so come down, go through it sort of like a cubic, and then come back up. Not quite sure why our scale is so off here. Let's go look at the picture and see if we can figure that out. So we had, I'm going to clear that out, x minus 1 to the 4th power minus 4 times x minus 1 to the 3rd power. Right now, our window is what we had it set before, negative 5 to 5, negative 10 to 10. Let's just look at it on that window. All right, there's our area that looks like a cubic. We went through 5, and we come back up. So it does look like it goes way down here. So let's change our window a bit, and we'll stretch this one out until 6, because that's what I see over here. We'll go down to negative 30, and we can count, go up to, let's keep it at 10. We can count by 3s. That's fine. Okay, so we should come through. There's our cubic looking part, and that's why we went down so low there. Our minimum is really far down. So let's find our minimum. So our minimum, the left side of my minimum, 1, 2, is about 3. On the right side, certainly 5 is on the right. So my guess is that it's about 4. Oh, whoops. I want to calculate the minimum, not the maximum. So minimum, left side 3, right side 5, guess is 4. All right, minimum is at 4, negative 27. So let's come in and make that. So we moved the whole thing. Well, let's just come up here. All right, so this should have been a bit higher. 1, 2, 3, 4, 5 is up here. Come down, go through it like a cubic. 427 is here, back up to 5. Did I put my 427 in the right spot? Yes. And try and use a smooth line if you can. It's really hard for me on the tablet. Hopefully you did a slightly better job of making a smooth line and making this look cubic here. All right, that was a tough one to draw on this computer. Come see me with questions on that if you have it.